Good morning, everyone. This is Sejal Kumari before you, presenting my shop talk on the topic Field Programmable Gate Array, or FPGA in short. These are technologies whose full significance and capabilities are beyond what can be inferred from the name alone. Coming down to the history of FPGAs. So, circa in the mid 1980s, they were originally perceived to give designers the ability to create custom digital logics. And by the early 1990s, they were primitively focused with the telecommunication and networking only. By the end of 90s, they were being used by the consumers, automotive, and by the industrial applications only. Let's have a foreword on it. FPGAs basically typically belongs to the class of devices which are known as programmable logic, or sometimes even referred to as programmable hardware. Essentially, an FPGA doesn't do anything on its own. However, it can be reconfigured again and again to behave as any other digital circuit that we want it to be. The magic here is that nothing changes physically. You just have to load the configuration onto the FPGA and it starts behaving as one. It requires no soldering, no jumper wires, no fuss at all. In fact, there is a characteristic of it which is called the flexibility. So FPGAs allow for reprogramming. It can be reconfigured to behave as any another digital circuit that we want it to be. There are different parts of FPGA, as you can see on the screen. The first one is the programmable interconnect, the I/O, input-output blocks, and the logic blocks. Moving on, there's also this integrated circuit that you can see on the screen. This is how basically it looks, and this can be configured. So it's in hardware that can be reconfigured as per our choice and need. Now, how does an FPGA work? So a field programmable gate array is an integrated circuit that is designed for the customers and can be and for the designer after manufacturing, and hence it gets its name, the term field programmable. There are basically two critical aspects of it which allows them to get programmed. The first one being the configurable logic block, which is the basic logic unit of it. And it gives the FPGA the ability to accept different hardware configurations. So we can program it. And these configurations involves number of discrete logic components that includes the lookup tables and the flip-flops. Moving on, we have the I/O blocks, which are input-output blocks, which gives them the interface with which for the external devices. For the digital circuits, we have microcontrollers, and for the analog ones, we have the actuators. Sensors go for hand in hand in both the circuits. Why should one use FPGA instead of any other type of integrated circuit? I mean, there are so many ICs, but why go for FPGA? Why choose FPGA over them? So the answer lies that the primary advantage of using an FPGA is that they are known as programmable fabric. So they allow the designer to allow the designer to rapidly program or reprogram, and they can perform nearly any function, whichever we want. Other type of ICs, such as the microcontrollers, microprocessors, application-specific integrated circuits, and application-specific standard products, they are mainly have a fixed function upon deployment, and they are programmed sequentially, that is one after the another. The lack of programmability can contribute to shortening the lifespan of the system once they are deployed. And the serial processing can lead to higher power consumption, as the ICs use higher speed clock frequency to keep pace with the processing workload. This is problematic for applications that require higher compute programming, such as the edge AI, where support for low power operation is also required. So that is the reason they are highly advisable to be used by programmers and the designers, the high-end people who need a proper to be flexible around the application. So it provides that. There's a bird eye view of the FPGA as well. This is how it looks on the microscopic level. Now, which FPGA should I buy? Now, there are mainly 4 of them. So the right FPGA would be that supports your design on the application you're developing. The Lattice Semiconductors is known as the leading provider for low power, highly reliable, and small form of these like FPGAs. The general purpose ones allows a broad range of application needs. The embedded vision is used for the video bridging. The ultra lower powers are used for space constrained applications, and the system control and security are basically employs platform management and security. They are used for that. Designing FPGAs into a system. Now, how is FPGAs used in the system? While there are many advantages to FPGAs, such as the speed, the reliability, they are flexible. There are many trade-offs associated with them because they are known as programmable fabrics, and which allows a designer to rapidly program the device to perform nearly any function. So that is the main agenda. That is their main propaganda. They allow them. And National Instruments, they offer an entire family of FPGA-enabled devices, which are both packaged and board level for our programming needs. Some of them are displayed on the screen: the single board controllers, the industrial controller, modular instruments, and RF instruments. And there are many more. FPGA applications. Where are FPGA used? Nearly everywhere. Everywhere as you can think of, they are used there. So FPGAs are used for all kinds of applications. Specific applications using an FPGA include the digital signaling, signal processing, biomedical instrumentation, device controller, software-defined radio, and random logic, medical imaging, and for computer hardware emulation, voice recognition, cryptography, filtering, and communication encoding, and more, many more. The consumer can actually buy it for electronic applications, including the smartphones, autonomous vehicles, cameras, displays, video and image processing, and security systems as well. Many commercial applications are also there, where using FPGA is very advantageous, like in servers, various markets, including the aerospace and defense. They're used in the medical field, and distributed monetary systems as well. If you see in the medical field, they are used for diagnostic and therapy applications, where we use the Vertex and the Spartan trademark FPGAs. For the military use cases, we have the radar systems, we have unmanned aerial vehicles, UAVs, they are used there. And for the critical infrastructure, if you see, they are used in the high-end platforms, they are used in the industrial control systems, they are used in transportation systems as well. What comes up as a closing thought is that FPGAs reduces the downtime, they reduce the software cost, and all of that while increasing the efficiency. A single FPGA can actually be instantly reconfigured to support different application needs across harsh conditions. And with that, I come to the end of this presentation. Thank you.